Hello and welcome. In this episode, we will discuss the tool register, which is the main component of the MoldMaker system. We log into the system. Daily work with the system takes place primarily in the tool register. We see the main panel. On the left side, there is a side menu. In the center, there is the status section, and below it, there are various modules available in the system. The status section presents several pie charts showing the current status of tools. For example, we can see how many tools are currently operating and how many are not. We can see the overall status of all tools and the signal strength currently received from them. Above the charts, there is a button for configuring the visibility of sections on the main dashboard, where we can enable additional sections such as injection molding machines, presses, or recent activities. Now we see an additional section of pie charts for injection molding machines, including their status and the signal strength received from counters installed on them. Tool status indicators include parameters such as an overdue schedule, a service request, low battery, a temperature alarm, or a disassembly alarm. The activity section that we enabled shows a list of all recent operations performed on tools or injection molding machines and recorded by the system. In today's episode, we are focusing on the tool register. It is the main table used in everyday work with the MoldMaker system. In the table columns, we can see the current parameters of the tools. The tool register view can be switched between Tool View, Schedule View, or Calendar View. In addition, for each view, we can configure the visibility of columns. For example, we can disable the customer and note columns and enable the current machine column. The Schedule view presents the same list of tools, but with all maintenance schedule parameters visible. In the top bar of the tool register, there are filter options, a search field, and location filters. We will now move to the parameters of one of the tools. This is the main configuration page for each tool. Here we see the basic information section, where we define the tool name, the part name, assign a location, and set other basic parameters. Location can be, for example, the name of a specific area on the production floor, or even a different production hall. In the counter status section, we can see the current cycle count, the date of the last counter reading, and the date of the last counter increment. We also see the target cycle time setting and a bar showing the actual cycle time deviation. Below this, we see a cycle time table presented in period-based, hourly, and shift-based views, showing average cycle time, real cycle time, average efficiency, real efficiency, and the OEE factor. Here we can also run a performance analysis for any selected time period by entering the dates manually. A sample performance analysis includes calculations such as the number of cycles completed during the selected period, available time, non-productive time, actual working time, total downtime, downtime percentage, short stops time, and its percentage share. Short stops are tool stoppages shorter than 5 minutes. The system automatically detects such stoppages. The analysis also presents average and real cycle time, as well as performance. Average cycle time is calculated directly for the selected period based on the start date, end date, and total number of cycles. Real cycle time is calculated for the same period, but only for stable cycles, excluding downtime. In other words, it represents the theoretical cycle time that would have been achieved if no stoppages had occurred during the analyzed period. The analysis also includes OEE calculations based on standard formulas. We will now move to the list of readings. It presents raw data collected from wireless counters. We can see the date of each reading, the counter value, the temperature, and the disassembly sensor status. Now we will move to the charts. The tool operation chart shows tool performance over time. Using the quick selection buttons, we can display a yearly, monthly, or daily view, the last 10 hours, or a custom date range. The chart shows tool operation, downtime, performance decreases, and temperature. Using the range slider at the bottom, we can select a specific time segment and zoom in. We can also manually specify dates or select a range directly on the chart. The zoomed chart shows detailed tool behavior. For example, we can see several breaks in tool operation, exact times, temperature, and the duration of each stoppage. For example, we can analyze how the tool operated during the night. In another section, we can see a performance improvement that occurred after a longer break. We can assume that machine settings were modified, resulting in higher efficiency. At the bottom, we can run a performance analysis for the time segment currently displayed on the chart. A calculation window similar to the one shown earlier will appear. Now we move to the statistical calculations view of the tool. Here we see a summary of work in monthly and yearly terms. We see a table of the total number of cycles completed each month. We also see the total tool working time for each month and the same working time shown for each week. Now we move to the shift charts. The purpose of these charts is to compare production results for each production shift. The summary chart shows cumulative production, performance, cycle increase, and temperature. We can also use the options to compare individual shifts by selecting the parallel comparison mode and choosing a date. This allows us to see tool behavior across different shifts. Now we will discuss the remaining sections of tool parameters. The sub-counter section is available here. There are two sub-counters, which function similarly to trip meters in a car. Each sub-counter can be reset and started from 0 again. It is important to note that the main tool counter can only be reset by contacting MoldMaker service via the Help Desk module. Now we move to the disassembly sensor section. This is one of the interesting features of the MoldMaker system. Each wireless counter has a small button on the back that protects against unauthorized removal from the tool. The lock icon indicates whether the counter is currently attached or removed. We can enable monitoring of this button, and under the Removal History button, we can check when removal alarms were triggered. We can also configure notifications for the disassembly alarm. Below this, we see the temperature monitoring section for the counter. Here we can enable temperature monitoring and set the alarm trigger range. Depending on the counter type, the available temperature range may vary. In the temperature options, we can select temperature units and set an approximation factor. By default, the system displays the counter temperature measured by the built-in sensor, but we can switch the option to display the approximated tool temperature. Depending on how the counter is mounted, we select the appropriate temperature multiplier. The multiplier can be adjusted manually, and we can also add an offset if we want more precise calibration. Detailed explanations are available under the Help button. Next is the Status section. In this window, the system displays current tool statuses such as signal strength, NOK status, work status, and other alerts. The NOK status requires some clarification. It is a configurable status assigned individually to each tool and can be triggered by various events. The configuration is done in Settings, in the NOK Status Configuration section. Here we can define which events should cause the NOK status to be displayed for a given tool. By default, two events are set: Schedule Overdue and Service Request. Let's come back to Tool Parameters. On the right side, we have several buttons available. The Tool Specification Card button is explained in another training video. The Technical Documentation button takes us to the file storage server, where we can upload up to 1 gigabyte of drawings, 3D models, and other tool-related documentation. Maintenance cards, work orders, spare parts, and maintenance schedules are covered in other training videos. At the bottom of the screen, we also see the activity log window, which records all actions performed on the tool. Every parameter change creates an entry with the date, time, and author of the change. In this episode, it is also worth mentioning the tool register configuration. We go to Settings and then to the Tool Register Configuration section. Here we see options for Average Performance Calculation and Average Performance Reset. We also see checkboxes for displaying signal strength, showing schedule forecast details, and enabling additional column filters. When enabled, additional search fields appear for individual columns. Thank you for watching this episode. We invite you to watch the other training videos and wish you productive work with the MoldMaker system.